My campus is surrounded by nature, redwood forests, wide open fields, deer. And this morning, when we were leaving, and because I live near campus, we actually saw a coyote on our way here. It's almost as cool as when we get the email saying there's been a mountain lion sighting nearby. Many of these mountain lions have been tagged with a GPS tracking collar, and we tag animals because we're interested in knowing about their whereabouts. But as it turns out that as scientists, we can tag so much more than just stars. We can tag so much more than just animals. We can tag stars. So obviously we can't catch a star, tag it, and then send it back into the wild. What we do instead is something called chemical tagging. Chemical tagging is the process of identifying stars that form together based on common chemical composition. Much like tracking animals tells us about their migratory habits, chemical tagging informs us about the migration histories of stars. So stars in general form in clusters from a parent cloud of gas and dust. Certain clusters tend to just stay together over time, like a school of fish, united and swimming through our Milky Way galaxy. And we found that these star clusters, because the stars formed from one cloud, they have the same chemical composition. However, there are certain clusters that end up dispersed over time. So you can think about this as baby sea turtles. They're born from the same beach, but once they reach the open ocean, due to predators or waves, they get dispersed and distributed all over the place. That's what we think happened to our sun. So there may be siblings of the sun out there because they were born from the same cluster. If you compare elements such as iron, oxygen, calcium, they would have the same amount as our sun. As astronomers, we are interested in the factors that cause these star clusters to disperse. So it would be like wondering, what is the equivalent of a seagull swooping down and scattering sea turtles, or what's driving the waves that carry them away? By chemically tagging stars and tracing where stars from different clusters end up, we can learn about the development of stellar populations in the Milky Way galaxy. On top of that, we may even be able to find the stars that form together with our sun, the solar family, the sun's siblings. We are on the lookout for the Earth's aunts and uncles. And trust me, when we find them, it's a family reunion you won't want to miss.